Let's now go through how the capacitor is connected in the circuit and how it affects the capacitance of the whole circuit. Capacitor in series and parallel. The capacitance of the capacitor depends upon the permittivity, area of the plates and the distance between the plates. The formula is given as C is equal to E multiplied by A the whole divided by D, where C stands for capacitance, E stands for permittivity, A stands for area and D stands for the distance between the plates. Taking permittivity as constant, as the area of the plates increases, the capacitance also increases, whereas the distance between the plate increases, the capacitance decreases. Capacitors in series. When capacitors are connected in series, the total capacitance is less than any one of the series capacitors' individual capacitance. If two or more capacitors are connected in series, the overall effect is that of a single capacitor having the sum total of the plate spacing of the individual capacitors. As you have just seen, an increase in the plate spacing with all other factors unchanged result in the decrease of the capacitance. Thus, the total capacitance is less than any one of the individual capacitors' capacitance. The formula of calculating the series total capacitance is same as calculating resistance connected in parallel. Series capacitance is equal to inverse of Ct is equal to inverse of C1 plus inverse of C2 plus inverse of C3, where Ct is the total capacitance of the circuit. Therefore, Ct is equal to inverse of sum of individual inverses of the capacitors connected in series. Capacitor in parallel. When capacitors are connected in parallel, the total capacitance is the sum of the individual capacitors' capacitance. If two or more capacitors are connected in parallel, the overall effect is that of a single equivalent capacitor having the sum of the total of the plate areas of the individual capacitors. As you have just seen, an increase in the plate area with all other factors unchanged result in increased capacitance. Thus, the total capacitance is more than any of the individual capacitors' capacitance. The formula of calculating the parallel total capacitance is same as the formula of calculating the resistance connected in series. Parallel capacitance is Ct is equal to C1 plus C2 plus C3, where Ct is the total capacitance of the circuit.